Personally, when it comes to configuring our primary and secondary routes, I prefer the method we just used, using the root primary and root secondary commands. But you can change the priority manually with the spanning VLAN priority command. And we're going to do that in just a moment. Now, the switch isn't going to help you by saying, hey, the priority you set isn't low enough for the switch to be the primary or the secondary. So you got to know the priorities of the other switches involved to get the results that you want. You also have to be sure to enter the priority in increments of 4096. There's that number again, because if you don't, the switch is going to remind you to do so. Now, the exam might not, so that's a good thing to keep in mind. And let's go ahead and see that in action. Now, right now, switch 2 is still the root for VLAN 20. And let's go ahead and just run show spanning VLAN 20 because I'm like that. And we can see that switch 1 is currently not the root for VLAN 20. We know that inside and out. Let's say that we wanted to go ahead and make absolutely sure it's the root for VLAN 20 without using the root primary command. And what you can actually do, well, let me show you the command first, that would help. Spanning VLAN 20. But instead of using root here, we're going to use priority. So we've used all these commands now. And notice that iOS even mentions bridge priority in increments of 4096. Also note that you're only changing the priority for the VLAN or VLANs that you specify. So it might surprise you. It surprised me the first time I saw this, that you could actually set a bridge priority to 0. So let's go ahead and do that. No options after that. And there you go. So switch 1 is already the root, and you'll notice its priority is 20 because we set it to 0, and since we're dealing with VLAN 20, the system ID extension value is 20. So you add 20 to 0, and by golly, you have 20. And we see a couple of ports going through some modes there. 12 is in listening mode right now, and it should come out of that shortly because we know our ports are going to go through some different phases here since we just changed the root for VLAN 20. So let's see, with that in mind, I'm going to go ahead and take that off for right now. And all I have to do is put a no in front of it, and it should reset to the default. And not yet. The election hasn't finished yet. This bridge is still the root. And there we go. So I finally took a few more seconds there. We get so used to it being so fast that we have to occasionally just remember, hit the elevator button a few times, it'll run faster. This time it didn't, but the election has finished and switch 2 has taken back over as the root for VLAN 20. Now, speaking of all of these modes we have here, we're going to go ahead and go straight into a discussion of something called Portfast. Sounds good. It's a fast port, right? Well, what Portfast does, it allows a port running STP to go directly from blocking to forwarding mode. And the first time I read that, you probably having the same reaction the first time you saw it. It's like, wait, what? We spend all this time talking about it. It's very important. STP prevents switching loops. You never want to turn STP off. You should be very careful about changing the timers. You can't even disable the timers, right? We saw that in iOS help. You can't set them to 0. And now we're going to turn a couple of them off? Yes, we are, but in a very specialized situation. Now, you may use Portfast in other situations in more advanced studies, but this is the major one. If you have a host that has trouble getting an IP address via DHCP, configuring Portfast on that particular host's switch port may clear the issue up, because I've run into this in labs and real-world environments. What happens is the STP learning and listening stages can actually interfere with that host's DHCP address acquisition process. And the chances of a switching loop on a single port connected to a single host, I want to say it's non-existent. It's as close to non-existent as you can actually get without actually being non-existent. So Portfast is going to let us cheat a little bit, if you will, just a little bit in order to get that host up and running. And Portfast is going to come up with a huge message for you when you run it. Now, you can enable it globally. You can even enable it on a trunk, despite what the message says that we're about to see. But where you usually start with Portfast is by putting it on a specific port. So that's where we will start as well. And you enable Portfast on a per port level with spanning tree Portfast. Makes sense. Let's go ahead and see that in action. Let's go over to switch 2. And I'm going to go on interface 3. And I'm going to run spanning Portfast. And my options are disable, trunk, and cur. And we know that means, just it'll take that command. And I just enabled Portfast on this port. Now I'm getting the longest warning, still I think the longest warning that we get on a Cisco switch for anything. And we should take a look at this if it's that long. Portfast should only be enabled on ports connected to a single host, connecting hubs, concentrators, switches, bridges, etc. I love the etc. To this interface, when Portfast enabled, can cause temporary bridging loops. Use with caution. And it's also going to tell you that Portfast has been configured on this port, but it will only have effect when the interface is in a non-trunking mode. So that means to actually have it take effect, we have to make it an access port. So that's something. So again, I don't want to scare you off this feature for real world usage, because when you see a warning this long, it's like, hey, I'm never using that. But you don't want to take that approach. Again, it can really help if you have a host that just isn't picking up an IP address via DHCP. Portfast on that particular port leading to that host can really come in handy. Now we can actually configure Portfast on a trunk. And we saw there spanning Portfast and then using iOS help, we see trunk enable Portfast on this interface even in trunk mode. So let's go to one of our trunks, and we should have one on 10 and 11. And we still have the option. And we get a warning. It's not quite as long, but we still get the warning that it should only be enabled on ports connected to a single host. And of course you think, well, if that's true, why is it available for trunking? And occasionally you'll run into a situation where you might want to put Portfast on a trunk, but generally I avoid it. Again, can cause temporary bridging loops. Use with caution. So this is where the disable option can come in handy. You could just put no in front of it. That would be fine. And we'll just take Portfast off of there, but I want you to see that it is legal to put Portfast on a trunk, and you would simply use the spanning Portfast trunk to make that happen. Also, you can make it the default, but it's a funny little default, so let's work with that. Notice I am not in interface mode. I'm in global configuration mode right now. And this BPDU filter and BPDU guard, we're going to talk about at least one of them in a few minutes. But right now we're going to look at the default option here. Enable Portfast by default on all access ports. Interesting stuff there. So if I go with default there are no options. And when you run that, you're not going to get any warnings. Okay. So what you can also do to verify that you have it running on a particular interface, can you run show spanning Portfast? No, it's not going to show you anything. What you have to do, and I believe Portfast is here at the very end of it. And you can see right now it's enabled on interface 3 for VLAN 1, which is the VLAN that it's in and the only one that it knows about. If you had it on a trunk, you would see it for each particular VLAN here. And also, this is a good command to get used to, the show spanning interface command. We really haven't used it to this point. But you can see with show spanning interface, and then you're looking at a specific interface, you can see the path cost, you can see detailed information, Portfast configuration, port priority, path cost to root. That is handy as well. And let's run a couple of those while we're here. That's a good idea. And let's run cost. And you can see right there it's going to tell you for VLAN 1 it's 19. And again, that's only on that specific interface. And if I ran it on a trunk, it's going to show you the cost for each one. So this is a pretty handy little command. Let's go ahead and put priority on the end of that. It's a good way to pick up your port priorities and root cost. That's going to be interesting here. And you can see all zeros because right now switch 2 is the root for all of those VLANs at this point in our lab work. So an excellent command there. Again, it shows spanning interface, then you just specify the interface and then follow it with one of these options. And we'll look at one more here to see what detail is all about. And as you see, that's a lot of details going on there. And you're also getting it for each VLAN because right now Fast Ethernet 10 is trunking. So you get all kinds of information here as far as the designator route and the designator bridge, etc. We just keep going on from there. And again, that may be too much information for you. It also shows the BPDUs that have been sent and received. So some all interesting stuff there. Whew, time to take a breather from Portfast. What we're going to do next is take a look at a couple of more advanced switching features that really come in handy in the real world, because we have to be careful once we get the root bridge that we want. We have to make sure that nothing happens in the future where another switch might get elected root, because as we know, the root switch election, the root bridge election, it's a continual process. It's always happening, and you'll see exactly what I'm talking about in the very next video.